In this session, let us discuss the concept of batteries in the unit number 6 of Industrial Chemistry, Applied Science. Okay. So, what is battery? Battery is an electrochemical device or a cell that converts chemical energy into electrical energy. Okay. Chemical energy is converted into electrical energy. Electrical energy means in the form of voltage or current. Okay, so these batteries can be used as the sources of electrical energy, that too the DC form of electrical energy. So batteries can produce only DC, direct current, DC form of electrical energy. So the batteries are the one which produce the pure DC form of electrical energy. Okay. Further, batteries can be classified into primary cells and secondary cells. So, what are primary cells? In the primary cells, the chemical reaction takes place in only one direction. Means the discharge only happens once the cell is formed. It will be discharged only. It will be utilized, and after that, once it is discharged completely, it cannot be recharged. So that kind of cells are called as the primary cells. Okay. So example for the primary cells are alkaline dry cells, mercury dry cells, and Leclanche dry cells. These are some examples of dry cells. Okay. There is a difference between cell and a battery. So what is cell? Cell is a single unit of electrical source. So this can be considered as a cell. This is a single unit of electrical source. But battery is a combination of these cells. Okay, either connected in series or connected in parallel. So this can be considered as a battery. This is battery. So this is cell. Cell is a single unit of electrical source. Battery is the combination of these single units in any numbers. Okay, either in series, in parallel, or in series and parallel. So this can be this is the difference between cell and a battery. Right? Now let us discuss on the primary cells, how the construction will be. The primary cell, the best example for a primary cell is a Leclanche cell or a dry cell. This is the construction of primary cell. It will be consisting of manganese dioxide, MnO2, paste, ammonium chloride, NH4Cl. This is also a paste with zinc chloride, ZnCl2 as the solution. Okay. These paste will be enclosed in a zinc casing. This outer layer is the zinc casing. Okay. And this carbon rod, usually of a graphite, is inserted or placed at the center of this cell. Okay, this is the carbon rod. So this is the construction of the primary cell or a dry cell. Okay, so what is the working principle of this dry cell? Let us discuss. So usually these pastes will form the anode, and this carbon rod forms the cathode. Okay. At anode, what happens? Oxidation happens. Oxidation means liberation of electrons. This zinc will be converted into Zn2 plus liberating the 2 electrons. So Zn gives rise to Zn2 plus 2 electrons. Right? Next, at cathode, reduction takes place. Okay? Reduction means taking off the electrons. So that is called as reduction. So here, see the equation: 2MnO2 plus H2O plus 2 electrons gives rise to Mn2O3 plus 2OH. So this happens at the cathode, and the total reaction can be given as Zn plus 2MnO2 plus H2O gives rise to Zn2 plus Mn2O3 plus 2OH. Okay. Let us see whether these equations are balanced or not. So here one zinc is there, here also one zinc is there. two electrons are there. So here we have got 2 plus, so we can tell it as balanced. Here 2 manganese, here also 2 manganese, here oxygens, 2 oxygen plus 1 oxygen, 2 into 2, so here C, 2 into 2, 4 plus 1 oxygen. In the left hand side, here 3 plus 2 oxygen, 3 oxygen. So 3 plus 2, 5 oxygens, here also 5 oxygen, here also 5 oxygen. And if you come to hydrogen, here 2 hydrogens are there, here also 2 hydrogens are there. So this equation is balanced. Now see this equation, here 1 Zn is there, here is also 1 zinc, and here 2 manganese, here also 2 manganese, here 2 into 2, 4 plus 1, 5 oxygens, here 3 plus 2, 5 oxygen. So all of these equations are balanced. So these chemical interactions or chemical reactions gives rise to the electrical energy. See here, since in the oxidations electrons are emitting and here they are utilized, so there will be a motion of electrons when we connect a load to this battery. Okay, so one single cell can produce up to 1.25 volts to 1.5 volts. One single dry cell can produce 1.25 volts to 1.5 volts DC. Okay, DC means direct current. Okay, this is DC. So cell will produce, one single cell will produce 1.25 to 1.5 volts DC form of energy. Okay. So this is about the construction and working of the dry cell. And if you want more current, the cells should be connected in parallel, like this. If you want more current, the cells should be connected in parallel. If you want more voltage, then cells should be connected in series. Okay, this is about the primary cells. Primary cells are the one where the chemical reaction takes place in only one direction. Means discharge can happen only, they can't be recharged. Okay, this is about the primary cells. The best example for the primary cell is Leclanche cell. Leclanche cell's construction is this. This is how the reaction takes place and how much voltage one single cell can produce. And if you want more current, cells should be connected in parallel. If you want more voltage, cells should be connected in series. So this is about the primary cells. So looking down to the secondary cells, these are the cells where the chemical reaction can take place in both the direction. Means these can be, the chemical reactions can be reversed. Okay, if you consider charging and discharging, in secondary cells we can charge also we can recharge them. But in case of primary cells, once they are discharged completely, they can't be used further. But in secondary cells, what happens? Once the cell is discharged, they can be recharged again. Okay, so this is about the secondary cells. Secondary cells are also called as the storage cells or the accumulators, since they store the electrical energy and discharge, and again we can store the electrical energy and utilize. So these can be called as storage cells or the accumulators. So secondary cells are the storage cells and also they are the accumulators. Here what happens? The lead electrode will act as a, if you consider a lead acid battery is an example for this secondary cell. So what happens? Lead electrode acts as anode and lead covered with the lead oxide will act as a cathode, and 20% of hydrogen sulfate H2SO4 can be used as an electrolyte. So these secondary cells are widely used because they can be rechargeable. We will use them in the vehicles such as car, bike and buses or vehicles we will use, and also they will be used in the inverter circuits. For the inverter circuits, these lead acid batteries or the secondary cells, mainly the secondary cells can be used. Usually lead acid batteries, lithium ion batteries, all of these are the secondary cells, right? So this is about the batteries. So both of these primary cells and secondary cells will produce DC electrical energy. Okay, so let us conclude. Battery is an electrochemical cell that converts chemical energy into electrical energy. We have two kinds of batteries, primary cells and secondary cells. Primary cells, they can be discharged, nothing but the chemical reaction takes place in only one direction. Secondary cells, the chemical reaction takes place in the chemical reaction can be reversed, means it can be charged and discharged as well. So for the dry cell, Daclanty cell is the best example. So since in these chemical reactions electrons are liberated, so those electrons move within the battery, and also if you connect the load, current will pass through them. So what happens? Chemical energy is converted into electrical energy. So this is about the batteries.
So next question on the concept batteries. Question number 14. A device which converts chemical energy into electrical energy. Option 1 batteries, option 2 fuel cell, option 3 dry cell, option 4 all of the above or all of these. So a device which converts chemical energy into electrical energy. So batteries are devices which converts chemical energy into electrical energy. Fuel cell is also a device which converts chemical energy into electrical energy, and dry cell also convert chemical energy into electrical energy. So option 4 is the right answer for this question. Next question number 15. A cell in which chemical reaction cannot be reversed. Option 1 primary cell, option 2 secondary cell, option 3 solar cell, option 4 photocell. So a cell in which chemical reaction cannot be reversed, it is a primary cell. So primary cell is a cell in which chemical reaction cannot be reversed. Example for primary cell is a dry cell. Dry cell in which we cannot reverse the chemical reaction. So option 1 primary cell is the right answer. Next question number 16. A cell in which chemical reaction can be reversed. So option 1 primary cell, option 2 secondary cell, option 3 solar cell, option 4 photocell. So a cell in which chemical reaction can be reversed, it is a secondary cell. Example lead acid battery. So option 2 is the right answer. So solar cell and photocell are not related to this question. So these are not answers. So a cell in which chemical reaction reverse is a secondary cell. In which we cannot reverse the chemical reaction is a primary cell.